These programs are distributed under a Creative Commons Attribution, Non-Commercial, No Derivatives license. You may copy and distribute these programs free of charge. You may not sell them, and you may not alter them. These programs are part of a study examining the value of podcasting as a medium for medical education. If this is the first time you are viewing a program in this optics series, send an email to jyoungmd@gmail.com with your name, position, institution, and city, state or province, and country. Thanks, and enjoy the podcasts. Our last lecture dealt with power crosses, and today we're going to use power crosses to solve what would otherwise be a very complicated problem. And the problem's this. Let's say that we have a patient who is wearing the spectacles -4 +5 axis 90. This is the prescription we've been dealing with from the previous lecture too. Let's say that the patient has these spectacles on and is looking at a star in the night sky. What is the image that the star will form on his retina? Well, obviously it will form a point because he has his spectacles on, and that's the whole reason for wearing spectacles, is so that you can see things clearly. But let's say he takes his spectacles off and looks at that same star. What will the image be that is formed on his retina? And there are, of course, 5 choices. It could be a blur circle, meaning the circle of least confusion. It could be the vertical focal line, it could be the horizontal focal line, or it could be an oval with its long axis vertical or an oval with its long axis horizontal. And this is, on the face of it, a very difficult problem to solve, because what we're asking is to figure out where the conoid of Sturm resides relative to his retina, where the retina intersects the conoid, where the cross-section is going to be. And you can do that. You can sort of plot it out. But I'm going to show you a much, much easier way of solving this problem. And I don't think I've ever seen anyone else solve the problem like this. So this is our total power cross. And it's the total power cross that we've been dealing with from the previous lecture. And the power of the total power cross vertically is -4, and horizontally is +1. Now, before we kind of get into this problem, let me give you 3 more patients. Let's say that there's an emmetropic patient who's looking up at the nighttime sky without spectacles. Of course, without spectacles, he's emmetropic, he doesn't need them. What is the image that the star makes on his retina? It makes a point. What about a -1 myope without cylinder? He looks up at the nighttime sky. The star is going to cast a blur circle on his retina. What's the size of that blur circle? I don't know. It's some size. Let's say that we have a +4 hyperope looking up at the nighttime sky without spectacles or without accommodation. What is the image that that patient is going to have on his retina? It's going to be a blur circle too, this +4 hyperope. What is the size of that blur circle going to be? I don't know, but it's going to be a lot larger than the size of the blur circle of the -1 myope. So what we're going to do now is we're going to kind of plot out the size of the blur circles. This patient is looking at the sky. I'm going to say, well, vertically, this patient has 4 units of blur. It's as if he were a -4 myope, a spherical myope, if we're examining him only vertically. And I'm going to plot out, 4 units from the middle of this power cross. I'm going to make little red dots there, as I've done here. 4 units. I'm going to say horizontally, he is as if he were a +1 hyperope. He has some blur, but it's not as much blur as if he were a -4 myope. So I'm going to plot those little points horizontally, 1 unit from the center of the total power cross. And all that I need to do now is to connect the dots to see that the image on his retina when he's not wearing spectacles looking up at the nighttime sky is going to be an oval with its long axis oriented vertically. Very, very simple, but only simple if you use power crosses. Let's take another patient. This one has a prescription of -4 plus 4 axis 90. So his total power cross looks like this: -4 at 90 and 0 at 180. And again, we're being very careful to use the word at distinctly from the word axis because they have opposite meanings. His +4 cylinder axis 90 has its power acting at 180. So +4 -4 means that there is a 0 power at 180. Let's plot out the blur on this patient. We still have 4 units of blur vertically. We have 0 units of blur horizontally. We connect the dots, and we see the image formed on this person's retina is going to be the vertical focal line. That's where the retina is going to intersect this patient's conoid of sternum when he's not wearing spectacles.